Welcome. This is Alonso Cosmos. I'm going to take you through data cleaning and exploratory data analysis for our data sets, and it's a bio corpus for Luganda, for English to Luganda. As you can see, I used libraries like NLK kit, which is the natural language processing kit. And I was using packages like stopwatch, counter, and then I used a combination of packages, even word cloud. So first step here, I had to import the data using pandas. Function is read CSV, and for the sake of my laptop, which is a bit not too strong, so I had to only use 100 rows for processing. So here I wrote a function that could show me the non-stopward plot to show you how many words are there in terms of frequency. You see they has close to 200, people has close to around, I think, 70. I think this is a duplication which has to be cleaned. And then you have government, their word. So this is what this plot shows you the most, the number of words that are repetitive. So this corpus was was created using newspaper translations. So that's why you see words like district, government. So for our research topic, we want to tailor it and customize it more to medical. So this plot will be highly useful when it comes to seeing how many medical terms are now there. So you will want this to be fully populated with medical terms. The next part is using LDA. LDA is a package. There's a package called LDAVs, which helps you to extract topics out of data. So when you pass it, corpus, it's able to analyze it, and it sees groups, several topics it has understood from the data. You can see it has managed to see close to 4 topics and how related they are based on, as you can see, the distances. See, according to this, 1 is closely related to 4, and then 2 is also closely, not closely related to 1, but are from 4 are like that. So as you can see, 1, they show you the composition of each word in each topic. So if you look at this, you see that red color indicates like this is out of close to 140 something. There's only something like 45 in this 45V in this word, in this topic, and then there's something like 25 government words in this topic. You see, and as you go on seeing, you see that certain words keep on reducing in certain topics as others increase, and that the increasing words are the ones that form what the topic is about. Then I did some word cloud to show you which words stand out. As you can see, words like people are standing out more. Words like they, and as you see, the words that have very, very fewer fonts are very few, and that's why then those ones with bigger fonts are the ones that are standing out. Then I did perform some sentiment analysis on the data to know its polarity, to know if we have more negative and positive words, but you see most of the words are neutral since there is a high bar around 0, and then there are a few positive words, then there are a few negative. So our goal is to reduce the negative ones and increase the positive ones, because we are dealing with a sensitive domain, and that's the healthy domain. You have to make sure that the positive ones increase. And as we go, I try to write a function whereby I was labeling them. Those with less than 0, I was giving them negative. Those with 0, they were getting neutral. And then those with polarity 4, then those ones with greater than 0, were getting positive. So you see the plot in terms of neutral, positive, and negative. You see there is more positive than negative. That's good, but we also intend to get the neutral ones and increase the positives to make sure that most of the words that are translated by the model are positive. Yeah, that's for the exploration. Let's go to the data cleaning bit. First imported our data set, which is Canada.cs, which is a parallel corpus for English to Luganda. Try to this to get head and call the head function on it, which returns the first 5 observations. But you can increase this if you want. Try to give you something like the first 10 observations. As you can see, also I did info, which sort of give you some sort of short summary about the data set, how many English are there, words, how many Luganda words are there. So our data set has 2,000, which we intend to increase to close 1 extra 1,000, which will be composed of medical instructions and prescriptions. So it's good information. Then how many are now? I think there are these extra 2 columns, I think, which were created. And mostly they show you these columns and now have some sort of 2 to 3 now. Then I performed some cleaning to remove stop words. Stop words are words that usually carry no meaning during translations. Words like they, what, you, so many words that the stop words, they don't carry meaning during translation. So I had to clean them. As you can see, after cleaning, you don't see words like they. So I try to do a count of the most words you see. As now I cleaned it to remove there. As you can see, all the refugees were registered. As you see, without stop words, you only remain with words like refugees, requested, register, chairman, the meaningful words. As you can see, I'm able to remove the stop words, which are totally meaningless to this translation. So when it came to splitting, I was able to successfully split the database. I mean, to split the data set. I used 0.33. We can try to use some sort of something like 0.2. So I'm going to do that, but I'm having issues with my classifier. Specifically, I wanted to use random forest because it would be easy to play around with the hyperparameter, which is the maximum depth of the tree. I wanted to do some sort of text classification. Since didn't want to, my computer can't support heavy algorithms like I'm trying to do text classifications with TensorFlow, so I wanted to use the random forest classifier from sklearn, but I'm having some errors. Hopefully, as you can see, I was able to successfully split it into the training and the testing database using using a ratio of 0.8 to 0.2. I tried to call a random classifier, which is the random forest classifier on the data, but I'm having some few errors on when it comes to that part. Yeah, so I think that's it. I'll try to fix this bug hopefully today, because I wanted to see the accuracy and see if I can. I wanted to see the accuracy of this, but I was unable to, and it's coming to submission time. So this is the hyperparameter, just to be clear. The maximum depth of a tree is a hyperparameter which I was going to keep on tuning as I observe my accuracy here. Yeah, so it's failing at this point, but hopefully I can fix this and do another video, but if it doesn't, this is all I have. Thank you.